Let me show you the total hack for this, okay? Because it really is a pretty simple concept here. In this situation, we've got what the buoyant force is acting up, right? We've got the weight acting down, right? And the net force is going to be the buoyant force minus the weight, right? Okay. Well, the buoyant force is rho of the fluid, right, times the volume of the fluid displaced, which is the volume of the object, right? Okay, times g, right? And then the weight of the object, really, we've got the dimensions of it, right? Isn't it? It looks very similar, right? It's going to be the density of the object, right, times the volume of the object, or the fluid displaced, right? This is the volume of the object. It's the same volume, right? And then times g. Well, if you look at this, the densities are the only thing that are different, right? So you end up with this net force being the difference in density, right? In this case, what the density of the fluid minus the density of the object, right? Times the volume, really, it's really the volume of this object, right? Times g. So we can do this problem this way, right? Water is 1,000, so 1,000 minus 530. That difference in density, and this is always true for an object that is immersed in a fluid. You can take the difference in the density and find the net force. Now, sometimes it's downward, like if the object's more dense than the fluid. Sometimes it's upward, right? Times 9.81 times 0.05 times 0.04 times 0.04. And this is, of course, the volume. I'm doing rho GV. That's okay, right? So this is our volume, right? It's just length times width times height. Just try it. Take your calculator. Take your calculator and try it. Parentheses 1,000 minus 530 times 9.81 times 0.05 times 0.04 times 0.04. Boom. And you get exactly 0.3688856 newtons, which is about 0.37 newtons. Okay? Keep this in mind because these problems are hard. Okay, the net buoyant force is going to be just the difference in density. So really there's kind of a formula, right? The net force is the difference in density times the volume times g, right? Volume of the object times g.